Okay. So, hour 2.5 or whatever. Goodness. Okay. We just saw how to do some TDD, how to start working in IntelliJ. You saw me writing some code. You saw me doing some refactoring, running tests. I want to turn back to talking about sort of the course in general, and then time permitting, we might do a little bit more TDD tonight. So yes.
So being as you put an emphasis on the TDD, is that part of the grading criteria? Do you look at tests?
I don't.
If you don't have tests, do we get marked down for that?
Nope. So here's the thing. I'm encouraging you to do TDD. I don't know how to assess your tests, though. I could say something like, oh, yes, thou must have, 10 tests for project 1 and 20 for project 2. But then again, what keeps you from just saying, at test, return true, always pass, right? So, or I could say, oh, great, we have code coverage tools. You must have exactly what, 80% code coverage, 100%, right? So I just haven't found the right way to assess that yet. So, the dirty little secret is like, if you don't have to do TDD to get an A in this course. You just have to, pass the test cases that I send to your programs. It'll be easier for you to pass those test cases, though, if you take a test-driven approach. If you think about, okay, what does my code need to do? I want to verify that it does that every step of the way, and so then as I add more and more functionality to it, I can be confident that all the test cases will pass. So, yep, you can do it the traditional way, and I won't know the difference because you only submit the code that the main application code. You don't submit your test code. Maybe someday in the future. Good question. Yes?
I'm noticing on this page, and I've been looking at it more closely, I saw in Project 1 that it's due July 11th, 2 weeks from today.
Yeah.
And then in July 4th, it says assigned project 2. So I just wonder if that's an intentional overlap? Or...
That is an intentional overlap. Yes. So, more dirty little secrets about the course. Yes, there's only one project due every week, but you have 2 weeks to do each project, and so yes, they overlap. So then, what I recommend is that you get started on project 1 right now. Because I think as a number of you have come up to see, it takes a little while to get your environment configured correctly, and then you need to figure out how to use IntelliJ and your tools and and Maven to get used to this stuff. That's why project 1 is so simple. And actually, I'll talk about that right now. Great segue. Okay, so that student project that was just sort of like getting started, and that's something that I'll use to show off some TDD stuff. The stuff that really counts are the 5-phase phone bill application that you'll be developing throughout the rest of the course. So for project 1, it's a very simple command line application that does some kind of dumb stuff with your phone bill, but it gets you started. So in this project, it's all about creating 2 classes. One called two domain classes. One that's called a phone bill, and a phone bill consists of multiple phone calls. And the goal here is that you need to work some classes that you didn't write. So I have some classes that you'll extend and add some functionality to. And then also to perform some command line parsing. So yes, these first couple projects, they're all driven from the command line. And so then a big part of your grade, especially this one, will be your ability to detect errors in the command line, because there's really not a lot of other functionality in the assignment. So there's what I want you to do. Well, so I've got 2 classes that are off in my package, the edu PDX CS410J package, called Abstract Phone Bill and Abstract Phone Call. And your job in this project is to extend both of those classes and make concrete versions of them in your package. So that will be named edu PDX CS410J with your login ID. So there's phone bill and there's phone call. And because they're concrete, they must implement all of the abstract methods of the superclass. So there are some properties of these classes. Phone bill has a name of a customer associated with the phone bill, and it consists of multiple phone calls. And each phone call is initiated by a person with a given phone number at a given time, and is received by a person with a given phone number at a given time. So there's it's a caller and a callee, and they begin and ends at various times. There are two methods that are inherited from the superclass, get start time, get end time methods that use the date class. You don't need to worry about that. For this project, you can model all of the data for dates and times as strings. Although in a future project, you'll be using the date API. So if you want to use it here, that would be fine, but it's not required. These two classes, the phone bill and the phone call class, are used by Project 1 class. The name of the class is Project 1. And, and what it does is the following. It takes some information on the command line, information about the phone bill and its phone bill and one of its phone calls, such as the customer and then the caller and callee number certain times. And it creates a phone call based on the call information and adds it to a phone bill with a given customer name, and prints out the and will print out the toString value of the phone call if the -print option is available. So the command line has 5 required arguments: the customer, the caller number, callee number, start time, and the end time. And then it has 2 options, and notice that options appear before the arguments on the command line. One of them is -print, which will print a description of the new phone call, and the other one is -readme, which prints something called a readme that we will talk about next time. You can go look at the handout from week 2, but I'm not going to talk about that tonight. So I think I have an example down here. I hope I do. Oh, no, I don't. Okay, but anyway. I guess I can talk it over. And so then anyway, you have this command line program. Some things to note. So if you have like if you have an argument that has multiple words or has a space in it, you should limit them with quotes, double quotes, just like you would on any command line. The dates and times, however, should not be quoted. So meaning that there's a separate command line argument for the date and then another command line argument for the time. And remember, there's both a start time and an end time, both of which have a date and a time. Phone numbers have the form have 10-digit dialing, where each number is a number of 0 through 9. So these are the kinds of things that you need to validate. You need to validate the syntax of your dates and of your times and of your phone numbers. Here are some footnotes. I'll talk about what a POA is next time. Here again, you can read ahead if you'd like. I'll also talk about submitting. Note that customer names can contain any characters, including numbers. So basically, any text is valid for customer name. Don't need to do any validation there. And note that for this assignment, you should accept times and dates that have already occurred and also ones in the future. So date validation for this assignment is just going to be syntax. Don't worry about anything about a call ending before it starts or anything weird like that. Let's see here. Oh, note that the toString method on phone call is inherited from abstract phone call, and it's final. You can't overwrite it anymore. And we'll talk more about documentation next time. And note that while month and day can be either 1 or 2 digits, the year should always be 4 digits. So again, lots of validation in this assignment. Not going to do very much except for checking the command line syntax to make sure that's appropriate and make sure that's correct. A couple notes on error handling. Your program should exit gracefully, meaning that I don't want to see a stack trace. Error message is fine, but no stack traces. Examples of error conditions include the command line's messed up, like something's missing, or there's extra stuff, or the format of things like the phone number and the day and time. This one contains characters other than dash that are non-numeric. Right, that one of those things is messed up. Please submit all 3 files that you write, and please submit them in one invocation of the submit program, which again we'll talk about next time, et cetera, et cetera. So once again, there is a Maven archetype for the phone bill. Same stuff that was here is in the project 0 is in the student. Got to put this in your settings.xml. This time, and I cut over a page. That's kind of awful. I'll create a project for this also. So I'll create, use the generate again, and oops. And here it's the group ID with the phone bill archetype. It's going to ask me the questions. So the ID is the ID of like your ID, which in my case would be CS410J Whitlock. Artifact ID, I think it's phone bill is what I call it. Yeah, phone bill. And sure, use this for the version. Use that for the package. Yep, that's all good. So now I've created a phone bill. And it's the same, rigmarole that we just saw with student. This goes into a little more detail about all the things that are created, both unit tests somewhere. Yep, there's a phone call test. The integration test, I think I'll talk about that next time. Or I'll talk about it in the screencast that I prepare for next time. And again, you can do a Maven verify, which will go and compile everything, run the tests, build a jar file, run the integration tests. Yep, everybody seems happy. And then you can run the command line, target phone build jar. Missing command line arguments because there really isn't any. And again, you can take a look at the code by opening up that file that was created there in IntelliJ. New window, phone bill. Again, I want to add that to GitHub. And again, this has essentially the same stuff as we do in student. Maybe a couple more things, like there's a phone call. Phone call extends abstract phone call, which is my class. And all of the methods throw unsupported operation exception because nothing's implemented yet. And then you've got project 1, which creates no phone call, doesn't do anything with it, but we want to make sure that we can create it. And then just prints out, missing command line arguments, and then I guess it just iterates over the arguments. So if you see, if we put like 1, 2, 3 here on the command line, it prints 1, 2, 3 out there. Just a very simple skeleton to get you started. Same thing with the test. The test isn't terribly interesting. Oh, interesting. Okay, I guess it does have a couple of things that are really meant to sort of tell you some things about the fact that, yep, all the ways it's implemented is that all the phone calls have the same ID, and that it's okay for project 1 if the start time returns null. All right, this little thing to help you get started there. All this stuff is unversioned. Oops, let's look at it by directory, source, all this good stuff. So I'm just going to add this stuff to GitHub because I like doing stuff like that. And then say added files for the phone bill. Yep, from the for a project generated from project. So that was really fast. What questions do you have? So again, project 1 is pretty much in the same vein as the student project. There's more stuff to do. There's more parsing on the command line. Things are a little bit more complex, but it's pretty much all the same. I'm not going to go into the Maven site. You can try it on your own and see what it looks like. I'll maybe cover it like in an extra screencast or something. It's due 2 weeks from tonight. I realize there isn't class next week, so it's a little challenging, but I would encourage you to start early and ask your questions early and often to make sure that you don't get blocked, because realizing that we won't have in-person time next week, but I will make myself available for a couple of Google Hangouts. Question? No, you don't need to check for leap years. Yeah, and nor do you need to check things for like, the 13th month. Not for this assignment, for a future assignment you might need to. But by then you'll learn an easy way to do that and not have to implement your own like full date parsing. It's just really syntax checking. Yeah.
Is there like restrictions on using
Nope. If you want to use the date library, go right ahead, as long as it meets the requirements of the homework, the assignment, in terms of, like, 1 or 2 digit dates, and you must have a 4-digit year and stuff like that. Yep. So if you want to explore some of the Java date parsing APIs, I encourage you to do so, but it's not a requirement. And so then if you're just want to focus on command line parsing and doing simple stuff, getting Maven up and running, I recommend you do that. Okay. Really? Okay. Everybody feeling okay? Okay, good. So that's the phone bill archetype. One more assignment for the first day, because why not? Okay, the Java Koans. So I uncovered. Okay, a koan is a teaching question that's used in Buddhist discourse to get someone to think deeply about a problem. It's the sound of one hand clapping, right? One of those things, right? Their whole idea is they're supposed to be subtle and not tricky, but they're like little questions to get you, learning along the way, along a greater path to enlightenment. This dude out on the internet named Matt Bentley wrote some koans for learning the Java programming language. And what they are is a series of things that look a lot like unit tests. There's little code snippets that are meant to teach you about a particular piece of language syntax. And I started using these several years ago, and I found that they're a really good way to have you guys experience the language, not by reading a book or a tutorial or by a series of Stack Overflow posts, but by actually writing code and working there in your IDE. So I've adapted them to have a Maven archetype and to work and to make it so that I can grade them real easily. What I'd like you to do is, between now and really like the next month, I guess, July 25th, first 4 weeks, the first half of the course, work through these. And there are a lot of them, so again, sort of start this week, maybe do a couple every day, or a binge koan or something on the weekend. Please don't do that. That sounds really weird. To get a lot of them going. So I'll show you how it works. It's yet another Maven archetype. I really like these things. And here I added more things, so there's a little less typing to do. Yes. Okay, and so let's create a Koans directory. I'm just going to add it real quick. That's good to know. Oh, yeah. Okay. And I've got a whole bunch of things to add now. Yes, git commit added Koans from archetype. Okay. So I created my project. And I use a different thing. So the whole idea is that with these koans, there's a little program that drives it that basically says, oh, hey, I'm going to go through the koans in these order, and it'll tell you which one you still need to do. It's like, oh, this one you haven't done yet. It's still failing. You got to make it pass. And you run this. It's a little Java program that does this. And you run it like this. Great. And so it's like, okay, you're about to, so the first place that you start is this about koans.java. And it tells you there should be a method starting with @koan called find about koans file. Look within it for your first lesson. It gives you, so like this is the sensei sort of telling you, or we don't have senseis in Buddhism. Sorry, I'm showing my ignorance of Asian religion. Anyway, it's sort of like telling you what you need to do. So it's like ponder was going wrong in that method. So run this program in one window and then go to IntelliJ and open up that project. Okay. It was telling me there's a class called About Koans. So I use OpenApple N to go to About Koans. Okay. I'm going to get rid of that. Okay, so here it is. It looks a lot like unit tests in that, oh, you've got some methods, and they got this little cone annotation. So it's saying, okay, find About Koans file, and this is telling me, I'm going to get rid of this guy. It's saying, okay, find About Koans file is failing. Well, gee, why do you think it's failing? Yeah, it's being told to fail. So delete this line to advance. Okay, seems pretty simple. We're starting out simply. Okay, good deal. So I did that, and I'm going to go back to this, and it automatically saved in IntelliJ, and now it's telling you something different. It's like, aha, okay. It's talking about cone considered complete when it no longer throws an exception. So look at definition of cone completion method. Okay. So this thing is failing. What do we need to do to make it pass? Change the false to true. Yes. Go back. Look, we've now done 2 out of 271. Yeah, there are 271 of these things. Okay, now let's keep going. Okay, it's saying about assertions is the next class that we should look at. So about assertions. Okay, so it uses this little like dash dash thing to sort of say, hey, here's where you need to enter stuff. So okay, so assertions, these are similar to the assertions that you have in your JUnit tests. So we are asserting something that is true. Well, there are 2 possibilities, true or false. What would it be here? Yes, assert that true is true. Oops. True, oops, not the French spelling, yes. True, it compiles. Okay, we got 3 out of 271. Assert false. Don't worry, they get harder. Okay. Object null, magic keyword null. So what should go there? Null. Okay. What should go here? Null again. Yep. Good. Okay. Assert not null. What should we replace this with? What name an object? Any object. A float of 1. Does that work? Actually, let's wait a second. Let's take that out. So let's make sure everything else passed. Okay, so line 37. This is assert not null object. Okay, so now if we just take a float of 1. Yep, that moved on. We're now at 7 out of 271. But wait a second. Floats are primitives. Primitives aren't objects. What's going on here? It's actually not converting it to a string. It's converting it to a capital F float. Did you guys learn about the difference between the primitives and the wrapper types? It's in the lectures. But anyway, you can do this. So the primitives are automatically cast to object types when they can be. Okay. How about this? Okay. This is pretty easy. So hello world again. Assert 1 equals 1. Damn, buenas tardes. Or minus 5. 10 divided by 2 is 5. 5.0. Ah! Look at that. 5.0 is not corrected for 5, which is an integer, not 5.0. It'd be more interesting if it was like 10 divided by 3 or something. But anyway. Moving on. So this isn't teaching much about the Java language. It's teaching you about the Koans methods for like assert equals and stuff like that. So notice here that the assert methods can also take like a description of when it fails. So like the description says, right. So it prints out this description when it fails. It says it should be 42. So then of course 42 should equal 42, or maybe it's 6 times 7. Oops. Should be the right. Yes, there we go. Yep, that one worked. Oh, this is interesting. Okay, so assert same instance. So there's assert equals and there's assert same. Now equals and same are different. So it says that both so you have an original object and then you have the same, which is the original, and they have a different object, but they don't both have the value of integer 1. I don't know why that's. Oh, okay. IntelliJ is saying that you don't need to create, you don't need to autobox that, but whatever. So these two are equal. So original and same and original and different are equal, but only one of them refers to the same instance as the original. And which one's that? Same, right. So there's a difference between being equals equals, which means you refer to exactly the same object, as opposed to two objects that have equal value. So right, there's one instance of integer 1 and there's another instance of integer 1. Okay, and this next one is failing. Accepted 1, but was 1. Assert not same, and in this case it shouldn't be same, it should be different. Okay, so this goes on for a while. Let's see what the next one is. Okay, about equality. Okay, so, oops. There's a beginner and intermediate. Okay. So now we're starting to learn more about Java language syntax and how all of this works. So here again, we've got a variable that refers to a new object. And this expression right here, object equals some same object. Does this expression right here is a comparison? What does it return? What's the value of this expression right here? True, yes. And the one below it? Why? And this is when and this is what it's supposed to teach you, right? It's like, well, okay, you can figure out that it's false. But like, why is it false? And so then you can go and look up, what does the equals equals operator mean? And it compares two object references to see if they refer to the same object. And here you have, clearly you have that this object that you create here is different from this object that you create up here. And this is how you're supposed to use these Koans, is to like figure out what the answer is and then understand why the answer is. Now, will you do this for all 271 of them? No. Because some of them are pretty obvious, and sometimes it's going to be like, hey, I just got to work, I don't need to understand why. But that's the intent here, is that you spend a little bit of time with these, maybe a couple each day, sort of go through it and understand it. So like maybe like one of these, go through like one of these classes every day to sort of learn another little piece that you'll then be able to apply in your homework and your project assignments. So, and this is as far as I'm going to take it today, is go through the about equality. So, I recommend that you get started on this one and then just plug away at it a little bit every day. And again, that's due in. You have several weeks to do that, but then, as you pointed out, that's interspersed with all the other assignments. So, this is how we pack a lot of learning into 8 weeks. Okay. I want to do a little bit more TDD, and then I want to call it a night, because I think we covered a lot, and I think that's all of the other Koans. Yeah, that'll be enough for this week. So let's return back to our student. Let's let's see here. We'll say goodnight to that. Say goodnight to the phone bill. Here's our student. Oops. What's next for our student? What other functionality is there? Let's go back to the assignment, see if anything rings a bell.
I mean, you could check gender
or the list of classes.
Yep. Oh, what about the list of classes?
That probably needs to be important as well.
Needs to get what, sorry?
Is there a list of classes variable in there, or?
You know, there is not. What was the test that we would write to do something with that?
Well, to start adding a class Java to the students,
Mm-hmm.
means there is a class Java associated to.
Okay, let's write that test. So let's see here. At test, student is taking a Java class. Oops. Oh, I keep forgetting that. Okay, so what's the given?
keeping a schedule with it. Putting an array list that has Java in it.
Okay. Actually, you know what? Let's start using var. Okay, classes equals new array list, and then classes dot add. Sorry, I didn't explain what var is, did I? You've probably never seen this before because it's like brand new language syntax. So, ever since the very beginning of Java, I'll just do it this way. You've had to, when you had a variable, you had to declare it with a type. And this was nice because it made your code sort of easy to read and easy to figure out. You knew what the type of that was, and this was comforting. And the compiler checked that, and so if you got it wrong, you know, it would tell you this was fine. But it got a little noisy. It's kind of verbose, and it's like, you know, how important is that really? And so in Java 10, well, other languages like Groovy and Kotlin and probably Scala, also I'm sure Scala does it. They don't require this boilerplate. It's like, hey, listen, if you have a variable, you're a smart programmer. You know, if you don't want to declare a type for that variable, it's okay. You don't have to. Well, the Java guys finally realized it's like, yeah, it's probably a good idea. There's, you know, the compiler can figure out based on the right side of the assignment what the type of that variable is. It can still do all the checking that it always does. So now there's a new keyword called var that lets you get rid of all of that. And so now you can just say that, which is nice. And so now you still get the same compile time type checking that you would otherwise. So now if I try to add a new integer to this, the compiler complains and says, wait a second, this class is really an array list of string. You can't add an integer to an array list of string, which is good. So we want a class named Java. Okay. So this is the given. When what? So when what are you going to do here?
Create a student.
Okay. And then here, and then this is classes, and then GPA 3.8, who cares, and then gender doesn't matter. Okay, then what?
Do a certain size of the classes list is one. Just kind of affirm what you want to affirm. Otherwise, you do a certain.
Assert that, okay. So student, oh, I need to put this into a variable. And I'm going to show you a trick here. Refactor, you can say introduce. Oh, where is it? Extract variable. Call call it student. Yay, it's so smart. Okay, student dot get classes contains. How does that work? It contains port static method from. Oh my gosh! No. I gotta look up how to do this in Hamcrest. Wait a second. Hamcrest list contains, yes. Oh, that's new. Is collection containing? That sounds nice. Has item. That's the name of it. Okay. Has item from Hamcrest core matchers. Java. So I'm going to extract that into a variable so I can class name. Has item class name. Okay, well I added this get classes method. So sure, let's create that in the student. It doesn't return a string, it returns a list of strings. List of strings. Let's import that. And I don't want to do anything yet, so I'll just have it be unsupported operations exception not implemented yet. Oops. Let's throw new. Okay, so if I run this, yep, sure enough it fails because, oh, I called get classes and it wasn't implemented yet. Okay. Well, let's go implement it. What do we need to do to implement it? Declare what? Oh yeah, and what is it's okay, we can start there. What is get classes going to give us? Okay, right, that list of classes. So let's we gotta store that away here in the constructor, right? So let's put in a field. Let's have a this.classes equals classes, and we'll say create that field, and it'll be a list of strings. And it's saying, hey, listen, it can be converted to a local variable because you never use it any place. Well, that's a clue that we should use it someplace, like down here. Okay. Now let's go back and run this again and see what happens. Okay, it passed. Okay, so now we store the classes. Okay, that's cool. Now there was another test that we could have used because we added this get classes, and okay, that's all right. It's I don't know if it's really necessary. Actually, we really the only reason we added it was so that we could implement this test. I guess it's okay. It's showing us that we're doing it. How else is that class information used? Yes, it's used in the toString. Let's explore that. Okay. Public void. Students. Let's see here. So how about this? Java class shows up in toString. So we're going to do the same given when then. Contains string class name, right? So we want to say, hey, the toString of the student contains class name. Let's run that guy. And it fails because toString is not implemented yet. Okay, well, we need to implement toString. So we're going to implement for toString.
Right now we just wanted to pass that test, so we just wanted to return the list of classes.
Okay. Return this.classes. No, it doesn't compile. Ah, okay. List of classes. So what was it? Required a string because it was returned a string, but we gave it a list of strings. Okay, so we need to change this to be a string. How can we do that? String.format. Okay. Other ideas? Oh, look at that. Okay. Actually, I kind of like this better than this because we had to add this get classes method. I kind of didn't have a reason. So how about we just delete this one then? Actually, well, first of all, we'll delete the get classes. Don't need this anymore. Actually, oh, look, we can say IntelliJ, just undo that. Roll back those lines. No more. Go back to the test. This thing can go away also. Okay, we'll run all of our tests again, make sure that's okay. Yeah, cool. Any opportunities for refactoring? No, don't see any there. I was looking at student here. I want to put this into its own method. I think it'd be easier to read that way. So I'll extract a method which is validate GPA. I think that makes it a little bit easier to read. Because hey, you're going to have to validate gender and stuff eventually too, and so then it's like, having all that logic there. Another thing that the clean code guys advocate for is small methods because they're easy to reason about. You can sort of see, so it's like having it do one thing and one thing well. And so in this case, I think the constructor is easier to read when you have like a method like validate the GPA. Okay. Interesting. Okay, awesome. So that's the Java class shows up in the toString. And let's see. Oh, I made a change, so I should test it again. Yay! And everything worked. I'm also going to go back to the command line and make sure that everything works here. Oh, and I'm going to show you something else. So Maven Clean, what that does is it deletes all of the stuff that you have, all of your class files, basically everything in that target directory, all of the intermediate files that have been created from your source code. So I'll do the clean, and then I'll do the verify. Cool. Okay, so that's all good. Let's get ready to check it in. So 42 on version files. Oh, that's stuff from the cones. Oh, interesting. Huh, wonder what that's all about. Okay, I'll have to clean that up later. Because right now we just got. I committed those. Interesting. Okay. And then, okay, so added a unit test. What did the unit test do again? Oh yeah, for the classes. Okay. Class name showing up in the toString. Okay. So, tonight we've started to write code in Java. We're leveraging some tools very heavily. One of them that we're leveraging is Maven. Maven helps us get started through its archetype mechanism. So we saw both for the student class and for the phone bill application and for the cones, Maven helps you get started. by sort of like laying out all these files that you need so that what you can focus on is writing the code, not worrying about the build system and not worrying about the tools and only executing a couple of things from the command line. We also leveraged IntelliJ extensively to help us see our code, to help us edit our code, and help us run our code, right? Running the test. You can also run stuff from the command line. These are the tools that I want you to get familiar with over the next week. It'll help you do your work faster. I know perhaps maybe in some of your other courses they've de-emphasized the tools, thinking that's somehow cheating, or it's like, oh, it makes things too easy. Well, I want writing code to be easy so you can focus on solving harder problems. I mean, come on, let's be realistic here. So we've also seen tools like GitHub that help us keep track of our code, help us organize our code, and help us share our code with everybody else. So let's see here. We also saw our first two assignments, your project 1, where you're going to be implementing classes of your own, writing your own command line program. And then we also saw the Koans, which are meant to give you little bits of introduction to the Java programming language, its syntax, and its constructs. Okay. Yes?
Is there a resource we can follow along with for when we're setting up our environment at home?
I don't have one prepared because honestly, it's like everybody's got a different setup on. They're like, someone's working on Ubuntu, and I need to give them special care then. So I think the getting started slides and screencasts, I realize now it's a year out of date, but I think all the concepts are the same. You might need to change some of the paths. But here again, what I recommend is that try it, reach out in the community. Other people might be having the same problem. They might be able to get to your questions first, faster than I will. But if it's like, if it's Sunday night and you're still having problems getting your environment set up, you need to speak up because, the longer it takes you to get it off the ground, the further behind you're going to be. So, please focus and concentrate on getting these tools working for you in your environment over the next couple of days. Okay. Okay, so we will not see each other next week because it's Independence Day. Instead, what I'll do is I'll put together a screencast. It'll probably be a pretty long one. I mean, it'll replace a 2.5-hour lecture, and so maybe I can squeeze that down to 2 hours. I don't know. No, you probably can't. Yeah, just watch it at double speed. I'll talk so fast. It'll be, yeah. And so I'll give you the information that you need. We'll be doing more stuff with test-driven development. I'll talk about integration tests, which are a slightly different beast from the unit tests. I'll also introduce some important information about how to document your projects, how to submit your projects, and then introduce you to Project 2. And so we'll try what it's like with the screencast, but please set aside some time to cover that information, and it will be multiple hours, just the same that you would have done going to class. Okay, and I'll also get everybody registered for, I'll get as many people registered for the course as I can. So thank you again for a good first class. We'll see you again in a couple of weeks. Let me get this stuff here.